right up. Okay. 9.7. So these are going to be using applications of what we just did in 9.6. So applications of exponential equations. Okay. In these problems, here is going to be your formula. Hang on. So the formula that we are going to use for this section, and I'll go over what all this means here in just a second, is P of t equals P sub 0 of e to the kt power. So P of t is going to be your end amount of whatever we're figuring out. P sub 0 is going to be your beginning amount. The E is going to be just the E, your calculator button, E. K is going to be your rate in decimal form. And T is going to be the time or the number of years. All right, so on number 1, it tells me in 2012, the population of a city is 6.43 million. The exponential growth rate, which is talking about how fast the population is growing, is 2.56% per year. So the first thing that we're going to do is find the exponential growth function. So the first problem is going to have P sub t equals what? So we're going to fill in what we know here. So the first thing, P sub 0 is the beginning amount. What was the beginning amount of what was the population in the beginning of this problem in 2012? 6.43. So we'll do, or 6.43 million. So what comes after the beginning amount? The E. Your exponent is the rate times the time. So my rate is 2.56%. I need to change that from percentage to decimal form, which means I'm going to move this decimal 2 places to the left, fill in that open space with a 0. So in decimal form, it's 0.0256. So my K of the exponent is 0.0256. I don't know the T. That's what I'm going to fill in, depending on how far out I'm looking to see what the population will be in further years. So that's going to go in your first blank. That's what P of T, that's the formula that we're going to use. Okay. The second part says the population of the city in 2018 is blank million. So if it was 6.43 million in 2012, how many years am I going out to get to 2018? 6 years, right? It's been 6 years if I'm going out to 2018. So I am replacing the number of years, which is the T, with a 6. So I'm finding what happens when I replace T with 6. I'll have 6.43E to the 0.0256 times 6. And then I am just putting this in my calculator. 6.43. And then remember where your E button is. It's your LN button, but it's blue. So second LN will give you the E. And it conveniently goes ahead and puts us up in the exponent. So I'm just typing in 0.0256, open parentheses 6, close, hitting enter, and then rounding this to what? 1 decimal place. So 7.49, which tells me 7.5. So it will be approximately 7, if it's growing at this rate. In 2018, you'll have approximately 7.5 million people. Now, the next part of this says the population of the city will be 10 million in about how many years after 2012? So it's telling me the end amount of people is 10 million. It wants to know, if it's asking you how many years, it's going to be looking for a T, right? T is the time. So what do I know now from this formula? It says, when is the population going to be 10 million? 10 million is the end amount, which is on the left side of the equal sign. So 10 equals the beginning amount, which is always the same, right? It's always 6.43. Then your E. Then your K, which is your rate. It's also going to be the same thing, right? 0.0256. I'm looking for that T. What year or how many years is it going to take from the population to go from the beginning amount of 6.43 million to the end amount of 10 million? So what we just did in 9.6 was solve equations that had where you were solving for something in the exponent, right? That's what we just did. So before I do anything else, I'm going to get rid of this first. I'm solving for T. I'm going to get rid of that 6.43. So I'm going to divide by it. So on the left, I'm just going to write all this down on the left and then put it all in my calculator at once at the end. So I'm just bringing down the 10 over 6.43 equals, all I have left over here is the E to the 0.0256T. So now I'm to the point where I need that to come down. So what am I going to do to both sides? Since it's an E instead of regular log both sides, you're going to LN both sides, right? Because if what you're solving for is in the exponent, at some point it's got to come down. So I'm going to LN both sides here. So on the left, now I have LN of 10 over 6.43 equals, drop this down. I can drop down my exponent now because that's what that log rule says. So I have 0.0256T times ln of E. But remember, when I brought this down, and then it's times ln of E, what is ln of E equal to? 1. Good. So if this is just 1, what's the only thing I have left with this T? This 0.0256, right? So if I want this T to be by itself, I just need to divide both sides by 0.0256. So that'll cancel. There'll be my t by itself. This is what I need to put in my calculator. So the first thing I'm going to do is ln of 10 divided by 6.43. Go ahead and close that parenthesis. And you can go ahead even and hit enter and then divide this answer. So divided by 0.0256. And this one we are rounding to 1 decimal place. So mine rounds up to 17.3 since it's 17.25. So 17.3. So it is going to take about 17.3 years in order for the population to reach 10 million. All right, the last part of this problem, number 1. So yeah, there's only 6, but this is the longest one. Is how long is it going to take the population to double? It's called doubling time. Doubling time has a formula. T equals ln of 2 over whatever the growth rate is in its decimal form. So in this one, how long is it going to take the population to double? Well, the doubling time is going to be ln of 2 over whatever the rate was, how fast it was growing. So 0.0256. And then put that in your calculator, and we are rounding to 1 decimal place. So ln of 2, close that parenthesis. You can go ahead and hit enter and then divide that answer. So divided by 0.0256. And round that to 1 decimal place. So mine's 27.07. So I'm going to round it to 27.1. Is how long the population will take to double if it's growing at 2.56%. All right, number 2. Number 2 is just a doubling time question. All right, we're going to complete this table. So there's 2 countries. There's country A and country B. All right, it tells me that country A has a growth rate. It tells me this part. It tells me it's 2.4% per year. And it wants me to fill in this blank of doubling time. So we're going to use the formula that we just used on the last problem. Okay, because we're finding the doubling time. I'm using this formula. ln of 2 over the K, which is the growth rate in its decimal form. So if I move this decimal 2 places to the left, what am I going to have? 0.024. And then put that in your calculator. So ln of 2, close it, enter, and then divide that by 0.024. And we are rounding this to the nearest whole number. So mine's 28.8. So I'm rounding it to 29. It would take it 29 years for the population to double, growing at 2.4%. The second row tells me if a population doubles in 33 years, if it took it 33 years to double, what was its growth rate? To find the growth rate, we can just rearrange this. When you rearrange it to have K by itself, it actually just ends up being ln of 2 over the doubling time. That will give you the growth rate. So ln of 2, what was the doubling time? It took it 33 years. So I just have ln of 2, close it, enter, and then divide that by 33. Now this says to nearest 10th. It's in decimal form, first of all. I need to put it in percentage form and then round that percent to the nearest 10th. So 0.02100446. So the first thing I got to do is move it 2 places to turn it into percent. So I have 2.10, which is just going to be 2.1%. All right, number 3. So remember that section where we were talking about the money that we were putting in the bank and it was compounding either quarterly or semi-annually, and we had that formula? Mm-hmm. This one says, suppose that $19,798 is invested at an interest rate of 6.2%. Here's the difference. It says compounded continuously. Whoa. So that's the difference. We use that other formula when we had compounded quarterly or semi-annually. We use this formula if it's compounded continuously with the E in it. Okay, so the first thing we're going to do is find the formula that is going to tell us how much money we'll have in this account in how many years. So I don't know the end amount. I know the beginning amount and the rate. So P of T equals, what's your beginning amount? $19,798. Then the E, my interest rate in decimal form is 0.062 T. Okay, so that's what's going to go in the first blank. Then you're going to have a bunch of different things that say the balance after 1 year is blank. The balance after 2 years is blank. So what all I'm doing is replacing the T with however many years I'm being asked. So after 1 year, I'm just going to replace the T with a 1. So 19,798 E to the 0.062 times 1. And all of these we are rounding to 2 decimal places. So again, just putting this in my calculator now, 19,798. So remember where E is, it's the ln button, but it's blue. So second ln, and then type in your decimal or your exponent. That is a decimal. 0.062, open parentheses 1, close it, and round that to 2 decimal places. So I have 21,064, 0.326, so 0.33. Okay. Now, for sake of time, I'm not going to do every single one of these, because then it's going to say after 2 years, after 5 years, after 10 years. So again, all we're doing every single time is just replacing the 2 with the number of years. Okay. The last part of this question just says, what's the doubling time? In other words, how fast is my money going to double? Doubling time is this formula. So T is going to be equal to ln of 2 over the rate, 0.062. So ln of 2, enter, divide that by 0.062, and we are rounding to 1 decimal place. So mine's 11.17, which just means it's going to be 11.2. So it'll take it 11.2 years to double. All right. The last 3 problems are literally, they're just going to give us a formula like this. They actually give me the formula, and we're just going to be replacing that. So on number 4, the number of books in a small library increases according to the function, and then it gives me the function. B, books, 7,800. E to the 0.03 T, where T is measured in years. How many books will the library have after 4 years? So I'm just replacing the T with a 4. So after 4 years, I'll have 7,800 E to the 0.03 times 4. These are multiple choice, and they're rounding to the nearest whole number. So 7,800, second ln, so E, and then my exponent is 0.03 times 4. So what's in your calculator should look like this. Enter, round that to the nearest whole number, so 8,794. Okay, oops. All right, number 5 and 6 are the same exact thing. They're gonna give us a formula and then say how many blank after so many years. So on number 5, the population of a small country increases according to the function B equals 1,600,000 E to the 0.04 T, and it wants to know how many people will the country have after 10 years. So just replace the T with a 10. So 1,600,000 E to the 0.04 times 10. 1,600,000 E. So second ln to the 0.04 times 10. And then round that to the nearest whole number, which will be 2,386,920, because it's 0.5, so the 19 will round up to 20. Okay, number 6, same exact thing. It's just going to give you this formula with a T and its exponent and have you replace the T. And that's it.